Yo, what's up, guys? Today we are working on an extended problem of the Fibonacci kata on CodeWords, which I've made a video a while ago. The goal of this kata is to generalize the sequence into any number of elements for the starting list. For example, if we have a signature of 1 and 1, which is the signature of the Fibonacci sequence, the resulting sequence would be the uh, 1, 1, 2, and 3 and 5. So the way we generate the next element is by summing the previous two elements in the signature list. Let's say we have another list of, say, 5 elements, 1 and 2, like this. So in order to generate the next element, we have to sum the previous 5 elements in the signature list. So the resulting list would be something like this: 1, 1, 3, 2. So when we summing the previous 5 elements, the next element would be 5 plus 3 would be 8, right? And then the following elements would be summing from the previous 5. So we keep going like that, etc. So this is 15, etc. So our function here will take in a signature of an x element, so however many elements there are in the signature, and a variable n, which is the number of elements in the resulting list. So let's say we have this signature here, and we want a list of 7 elements. Then this is the resulting list. Before we start coding, I would really appreciate it if you smash the like button for this video. The function we are defining is called Fibonacci, which takes a variable of signature and n, which is the number of elements in the resulting list. Since the way we generate the following elements is by summing the previous elements of the signature list, I will call x as the length of the signature, and this x is the how many elements we are going to sum to get the following elements. If n is less than or equal to x, then we will just return the signature where from the beginning to end, right? So for example, if the list is 1, 1, 2, and 3, and we want to get the first 3 elements, if n is equal to 3, then the resulting list will just be 1, 1, and 2. And if n is equal to x, which is the length of the signature list, then the resulting list will just be signature itself. And this is, and the way we do that is by slicing the list itself, and we will get the result we want. However, else, if n is greater than x, then we have to loop. We have an iteration to looping through h to generate h element by summing the previous x element in the list. So for I in range n minus x. This is to make sure that the total number of elements in the sequence would be equal to n. We would append signature dot append. So we are saying sum of signature from the previous element, from the previous x element, right? So this would be, if x is equal to 4, then it would summing from the last 4 elements to come up with the following elements. So for example, we have a list like this, 1, 2, 3, and 4. And if we are slicing from the last 2 elements, we will get 3 and 4. So we are basically summing the last. If we're doing summing of this, you will get 7. So we are using x as the way to slice the signature list, as we are appending the following elements to the signature. So as the list grow, say after summing the previous 2 elements, the signature list will grow to 7, and then in the next iteration we will append 11, and then etc. until I is equal to n minus x minus 1, I guess, because range doesn't take the last number. So after all the iterations is done, we can return signature. So we can test this list as well. Fibonacci of this, and let's say we want 20 elements in the sequence. So wow, okay, so we can tell that the list grows really fast. So it's summing the previous 6 elements, right? So summing 6 and then 6 elements, so on and so forth. So now let's check our solution on CodeWorks and see how we are doing. Let's test this. So Fibonacci is not defined, so all we have to do is capitalize X. Okay, so we have passed all the tests, so it looks like this function works quite well. So let me know if this solution is okay, and thank you for watching as always.